On the temperature, continuing from part 1, so here's part 2. So with temperature, we said the SI unit was Kelvin, and it's not degrees Kelvin, it's just Kelvin. But more familiar to us in the United States, we have degrees Fahrenheit, and the freezing temperature in Fahrenheit is 32 degrees Fahrenheit, and the boiling point of water is 212 degrees Fahrenheit. Now, Celsius is more commonly used in science, and that's what we'll be using in class. Degrees Celsius, you have freezing at 0 degrees Celsius and boiling at 100 degrees Celsius. And you can see why this might be a little bit easier to use. But regardless of the unit, when you're looking at a thermometer, so if this is our thermometer reading, you have your mercury or alcohol, depending on the type of thermometer, and it's going to be colored so that you can see it, and it's going to make sort of a reverse meniscus. Instead, now our curve goes upward. And what you're going to do is you're going to read at the top of the curve. So it's the exact opposite of what we said with volume. So if I were reading the temperature on this thermometer reads 33, well, not 33, let's see, 30, 31, 32 degrees Celsius. So 32 degrees Celsius would be what I would write down if I were recording the temperature. And then lastly, we have mass or weight. And we're going to talk about how those two are different. The SI unit for mass is a kilogram, and there are 1,000 grams in 1 kilogram. But now, mass is something that would stay constant. It's talking about the amount of matter we actually take up. But weight is actually a force. So weight is the force that we actually put down on the earth. And that's gravity effect on our mass. So literally gravity times mass equals your weight. So gravity is a big factor. On the moon, we weigh less because gravity on the moon is less than gravity on Earth. So weight is quite a bit different than our mass. But for mass or weight on Earth, when we're doing it in class, we're going to be using a triple beam balance. You place your object on the balance, and then you go from largest amount until you can get it balanced. So if I'm trying to do this semi-quick, it's not too bad. I'm going to go over till I start to get some movement. Too much. So I have 50 grams so far, and then I'm going to use my singular digit till I can level off my triple beam balance. And now you can see some motion. We're trying to get this to zero in right at 0, 0. So I'm a little off here. If I scoot back just a little, right just over it, you kind of have to have a hair trigger on this. Just slightly move it. All right, so now we're right at there, right at what we would be. So we would be at 56.1 grams would be the mass of my rock, and that's using a balance. So just to review, we had mass versus weight. Mass is not affected by the force of gravity. We have temperature. We traditionally will be using Celsius. Remember, we measure from the top of the curve on the thermometer. We have time, the standard unit being seconds, but we are familiar with seconds, minutes, and hours. Volume is the space occupied, which we'll either be using a formula or we'll be looking at a graduated cylinder where we're reading the bottom of the meniscus, the very bottom of the curve. We have length, which is traditionally going to be in meters, centimeters, or millimeters. And remember, we're using a meter stick, which is 100 centimeters. But if we zoom in, each of our centimeters is divided into the tiny little millimeter marks, and there are 10 millimeters up for those. So just to recall, measurements for Earth science.